Hello and welcome to the Stutzman 52 channel. My name is Terry. Now if you have a pool, this video may be of interest to you, and we're going to be talking about pool pump motors. Let's take a look at one right here. We got one that's seized up. We cannot turn it. Shaft is seized. Now let me know in the comments if you guys have any kind of issues with this. This motor was put in last year. And then the pool was shut down for the winter, so it was closed for about 6 months. So this here pump hasn't run in 6 months. So what I believe has happened is that imagine that you have a hunk of steel or iron and you threw it out outside and left it in the moisture and the rain and everything. It's going to get a pile of rust. And that's what I believe has happened to this motor. The rotor, which is made up of steel and iron laminations, is basically got rust on it and is frozen to the stator core. That's what I believe has happened. Now, I haven't opened the motor up, and we're going to go through all of that, and we're going to see what it is. I'm thinking maybe the bearings are okay, but who knows? We'll find out. Now, before we get into it, let's go over the nameplate. A lot of people don't understand some of the, some of this here literature and what it means, so we're going to go over that. Now, whether you have a A.O. Smith motor, or you have a Hayward Superflow pump motor, or a Century motor, as in this case, and by the way, Century bought out A.O. Smith motors. So, whether you have any of those three types of motors, this should all apply. Now, this right here is just the model number for the motor. It's a UST1102. And if you come down to the next line here, it says thermally protected. So this motor has a thermal overload inside, which is based on temperature and also on the current that's going through the motor. And we'll go through all of this in detail, and we'll show some wiring diagrams about it. But this is a part number for this thermal overload, and it's made by Clixon. Here's a motor model number. So it just gives you some more details about the specifications of the motor. The serial number represents when the motor was manufactured and in what plant it was manufactured. Now the first three digits, 304, indicates that it was manufactured on the 304th day of the year, which is October 31st. The next two digits, 23, indicates it was manufactured in 2023, and J2 means it was manufactured in a plant in Mexico. Here's the volts. This is the input voltage, so you can wire this motor for 230 volts, or you can wire it for 115 volts. Okay, this is the kilowatt rating, so it's 0.75 kilowatts. Horsepower rating is 1. 1 horsepower equals 746 watts. If we come down to amps, we can see that the amps on this motor is 7.5/15. Now, the 7.5 amps is going to be rated for 230, and the 15 amps is going to be rated for 115 volts. Now, this is the full load rating of the motor. Okay, this is a phase. This runs on one phase. It's a single phase motor. Okay, now we're at the code. The code letter here is a H. Now NEMA has specified code letters from A to V, which represents the locked rotor amps. And this is a kVA rating per horsepower. If we go and look up the rating for H, we can see that it has a 6.3 to 7.09 kVA per horsepower. What does that mean? It sounds like gobbledygook. Now basically what that's saying is that if you was to, when you first crank this motor up, at the very instant the rotor is at rest. So it's going to be drawing a lot more current than the full load amperage of this motor. So how can we calculate that? Now, I just mentioned that it had a kVA rating to horsepower from 6.3 to 7.09. Well, let's go right in the middle of that. That's going to give us 6.695 kVA per horsepower. Now, let's look at an equation of where we can actually take that rating and then convert it over into an amperage, which was what we would most likely want to see. So let's go ahead and plug in some values for this equation. If we take 6.695 kVA per horsepower, multiply that times 1,000, and then divide it by 230 volts line voltage, and then we can see that for our lock rotor amps, it's going to be 29.1 amps. When we take a look at the RPM, we see that it is 3450. Now this is the slip speed of the rotor. Now the synchronous speed of this motor is 3600 RPM, which is the speed of the rotating magnetic field that's going around the stator windings. Now, this tells us it's a two-pole motor. Now, if we were to go ahead and think about this, why does the rotor not run at 3600 RPM? Well, you got to remember that the rotor is always cutting the flux of the magnetic field that's being generated by the stator windings, because we have to cut the flux to be able to induce a voltage into the rotor, which then in turn is going to create a current, which in that current is going to create its own magnetic field, and then you'll have the interactions between these two fields, which is out of alignment. Now, if the rotor was to ever get to 3600 RPM, then these two magnetic fields would be in alignment with each other. Now, when the two fields are in alignment with each other, it's not cutting the magnetic flux, which means it's not going to be any voltage induced into the rotor, therefore no current, and then the rotor is going to start to slow down. And it's going to slow down until it reaches this here 3450 RPM. Okay, the frame, this is 56J. This is talking about the mounting flange, which is a C-flange or circular pattern, which is right up in here. It's a circular pattern. The 56 also denotes what the diameter of this motor is, which is 6.5 inches. The J represents that it is a threaded shaft, and you can see that it is threaded. And speaking of the shaft, this is a 5/8 inch diameter. The threads are 7/16-20 UNF-2A. So these are fine thread threads, and also the 2A means the tightness of the clearance between the impeller and the threads that's on the shaft. So it's basically telling you how tight or how loose those threads are when you screw that impeller on. 2A is right in the middle. Next on the list is a Hertz, which has 60. That means this, of course, is operating on an AC. That means there's 60 cycles in 1 second. One cycle is going to take 16.67 milliseconds. So if you take 60 of those cycles, that's what you will get in 1 second. Now this one right here says maximum load amp 7.5/15.0, which is the same amperage as we have up here. And that's going to lead us to the next one right here, which is SF. Now SF means service factor. It has 1.10. Basically, this is telling you that this is a motor that be rated for 1.1 horsepower. Now you see up here it says 1 horsepower. Yeah. But under some conditions, say you have an overload where it's going beyond 7.5, well then that's going to put this here, this is where the service factor is going to kick in. So you can have a higher amperage, all right, because you have a little bit higher, horsepower rating. That'll be your service factor. Now, that means your amperage is going to go up. So now they have what's called a service factor amps. So you can take this here reading, if it's 230 volts, it's 7.5. You're going to take 7.5, you're going to multiply it times 1.10, and what is that going to give us? So it's 10% higher, so that's going to be what, 0.75? If you take 0.75 and add it to 7.5, what is that, 8.25? I'm just doing this on top of my head, but you get the idea. So then now your pump motor can run at 8.25 amps, and it's going to be fine. Now some manufacturers say this is only intermittent, you know, it's not for continuous duty. But I looked it up on this manufacturer for this here motor, and they said that it was for actually continuous. So you could have this motor running at 8 1/4 amps and run continuous, and you'll be perfectly fine. Now we have the insulation class. It's listed as B. Now there are 4 different types of insulation classes. There's a Class A, Class B, Class F, Class H, and this is denoting the temperature, the maximum temperature that the windings inside this motor can handle. So the maximum for B is 130 degrees C or 266 degrees Fahrenheit. Okay? Now if we come over here, it says ambient. Ambient is the air temperature, the air that surrounds this here motor. So this motor can run up to 50 degrees C in an ambient, which is 122 degrees Fahrenheit. So I think for the most of the world, this would be a pretty good high temperature, unless you probably live in the Sahara Desert. Then you might have a little problem. Okay, here it says it's the continuous. It's a continuous duty. What that means that this motor can run 24 hours a day, 7 days a week.
Wow.
Yep, and the type is a UAC. Now everybody manufacturer has a different type, and what this is basically saying is it's an AC motor, and it's approved for pools and spas and things of that type of environment. Okay. All right, so let's go over. We go to the back of the motor. There's 2 screws here in the back. A 1/4 inch nut driver, 1/4 inch socket, loosen them up, and then we can just take this cover and we can just kind of pull it on off of there. Now, this motor, you see there's a lot of oxidation around the aluminum. That's aluminum oxide. This is where the aluminum, with a lot of moisture in the air, high humidity, reacts with the oxygen, and then you'll get this little powder. See, like right around in here.
Yeah.
That's aluminum oxide, right? Now, so what we're going to do is we're going to go through each one of these components, all right? And we're going to discuss them. And then we're going to talk about breaking this here motor apart, pulling it apart, and we're going to just see what's going on. Like I said, I think that the rotor has so much rust built on it, and there's a very, very small tight amount of clearance between the rotor and the stator core. So that rust just builds up over the period of months, and the next thing you know, it is seized. Now, sometimes you might get lucky. You could take a big old rubber mallet, and while the motor is on, of course, you know it's going to be humming, and it'll trying to turn, but it can't. Sometimes you can take a rubber mallet and just give it a good whack while it's on and humming. And sometimes you might be able to jar that rust loose, and it might be okay. My case, it didn't work. So now we're here to take care of this motor. Okay, I'm going to, right now we're going to set the motor up. And if you look right here, oh, by the way, on the other end of this right here, when we were talking about the shaft, you'll notice there's a rubber washer here. Now this rubber washer is called a water slinger. So we can just pull that right off. And the purpose of that is if the seal was to leak and water was to start coming through, that rubber washer prevents the water from coming down inside this shaft and getting into this here bearing that's on the front. So it's a last measure, so it's like a backup to keep that water from getting inside this here motor. Okay. Now what I did is I drilled a 3/4 inch hole right here in my tabletop in the garage here. And then we're just going to set the motor. We're going to just set it right up here so we can kind of see this thing. All right.
Well, aren't you smart?
Yep. So right now we have these components, and I will quickly go over them, but we'll go into more detail later. This here is a start capacitor. This right here is a thermal overload. This right over here is a plug, and all you would do is you move this plug from here if you want 115 volts or if you want 230 volts. It's just a matter of moving it from one end to the other. Okay, this right here is a terminal block. This right here is a centrifugal switch. And if we look right down in here, we can see that on the end of the shaft, we have this little mechanism, and this is called a centrifugal governor. Okay? And we're going to explain all the operation of all that stuff as we get into the motor a little bit. Now, I'm going to go ahead and I'm going to start taking this stuff off. Well, let's start with this capacitor. We have a 1/4 inch socket here, and I'm just going to go ahead and I'm going to take this here capacitor out. And we're going to show you how to check all these items here later on. So we're going to just keep that together. We're just going to put it over there. And I'm going to just take the screw. I'm just going to put the screw right back in there so we don't lose it. Okay. Now if we take a look at this capacitor, you can see it's rated from 161 to 193 microfarads, has a rating of 110 volt AC. So we're just going to kind of lay him down on the side over here. Okay. Now if we look up here on the top, we have our thermal overload. See, we got 3 wires on there. Now if we look right up in here, we can see that we have a screw right there. Again, that's a 1/4 inch. So we're going to take him out. So he fell down, so let me see if I can pick him on out of there. Alright, let's do this. There we go.
You go, that was quick and easy.
Just throw him out of there.
Yeah.
So we're going to set him over there. Now if you notice, look right here. You see how this here thermal overload is kind of sitting right there on that spot? It just sits there. It's got a little notch in it. So we're going to just kind of lift him up a little bit out of the way. Kind of sit him like so. Okay? Now we have the centrifugal switch. Again, we have a 1/4 inch socket. Let's pull him up. And also, before I forget it, let's just go ahead. I'm going to put that screw right back in there so we don't have these things rolling all over the place. And then we'll lose them. Okay, now we're going back to our centrifugal switch. Notice he's a silver screw. Let me screw him on down in there. Again, so we don't lose them. Okay, now you can see it's kind of just sitting all over to the side there, right? Okay, now if you're going to go through and you want to separate this motor, you don't have to take all this stuff apart that I'm doing now. The only thing you really have to take apart, just take this centrifugal switch off, take your capacitor, and you can leave this here thermal overload in, and that's it. And the last thing is you have to take this here centrifugal governor off because it's attached to the end of the shaft, and it has to come off before this here, you get this here end bell to slide off. Okay? But I'm just taking this all apart just so you can see everything here. Now we have our terminal block. Now that's going to be 3 wires connected underneath this here terminal block. There's going to be one that's on the A terminal, which is right here. Okay, so this is the A terminal. This is the L2 terminal right here. So basically the screw in these 2 male spade terminals. And then this is the L1 terminal along with its 2 male spade terminals. So we got 2 1/4 inch sockets. Let's go ahead and we'll lift that one up. There's one. And there's two. And then we can flip this over. And then see, here are the three wires that I had mentioned earlier that's connected underneath. So you can see the purple wire is going to the A terminal, the white wire is going to the L2 terminal, and the blue wire is going to the L1 terminal. All right? Okay, so we can just kind of lay all that over on the side so we can see everything pretty good now. And again, let me take these two screws here. I'll screw them right back in there so we don't lose them. All right, first, but let's see if we can go ahead and get this centrifugal governor off of here. Now what you'll see, a lot of them is they'll take these springs off, take them off, take this spring off, and then you'll see this here lever right here. Now this lever won't come out, so you'll see they'll take one side of it and they'll bend this metal to get this out, to get this, to be able to get exposed to this screw. Now we may have to do that. I would like to just be able to see if I can get this screw out and see if we can get it without taking the springs off and taking this here little lever out, and let's see if we can do that. So let me get a screwdriver. Okay, so I got a screwdriver. Now keep in mind that you can see the screw is partially covered over. But let's just see if we can break it loose. All right, so we broke it loose. But let's see how well it works in screwing this thing out. Okay, so you can see that it comes out without taking all this part, you know, and you can see that it's notched, all right, and you can see that it's notched sitting down on there, all right. It doesn't matter if it goes this way or if you flip it around this way, it doesn't matter. So let's set him right over there.